The polynomial function p is given by p of x equals x plus 3 times x squared minus 2x minus 15. Which of the following describes the zeros of p? So the zeros of p are the x values when p of x equals 0. So looking at this equation here, we have x plus 3 times x squared minus 2x minus 15. So this equation here equals 0 at different values of x. And one value we can see immediately when x equals negative 3. When x equals negative 3, then we have a negative 3 plus 3 here, which just equals 0. And so anything multiplied with the 0 is just 0. So this is one of our zeros when x equals negative 3. Now let's see if this term here gives us any more zeros. So let's factor this term here. We can factor it by splitting the middle term into negative 5x plus 3x. And then we keep the rest of the terms the same. So negative 5x plus 3, that just gives us back to negative 2. But now we can factor the x out of these first two terms and a constant 3 from these two terms. So we'll have x plus 3 times x minus 5. So we just took the x out of these two terms and then factor a 3 out of these two terms. So now we see that x minus 5 is common to both. So let's factor that out. So we'll be left with x plus 3 times x minus 5 times x plus 3. So now we see here the fully factored expression. This term gave us, as we saw earlier, a 0 at x equals 3. And we see that we have another x plus 3 here. So this would just give us the same 0. So we would just have a 0 at x equals 3 with a multiplicity of 2. But now we see here that when x equals 5, 5 minus 5 is 0, and so that gives us another 0 for our equation. So that means we have two total zeros when x equals 3 and when x equals 5. So that means p has exactly two distinct real zeros. These are real numbers, meaning that the x and y coordinates are real, they're not imaginary, and they're distinct, meaning they happen at two different points. So one happens at x equals negative 3 and the other happens at x equals 5. So A is the correct answer.